Hello, Tom from Every Step Calculus, everystepphysics.com. It's a Calculus 3 problem, X, Y, and Z. And this could be on a test, so certainly my programs can handle it. Let me show you how it works. Index 8. I'm already at line integrals. You'd scroll with this cursor down here, and of course the trick is to hold the second key down while you do that so you can go really quick down and up. There's 136 items in this menu, 460 programs that you buy for around $40, I guess, you know, no big deal. Look at the books you pay, look at the money you pay for books and all the other stuff in college. And this will certainly help you pass calculus. So we're going to press enter. And we've got X, Z, and Y. So here we go. Where's the function when here's f of X, Y, and Z right here, number 5. We're going to press that one. Choose the number in front if you want. Scroll to it if you want. We're going to enter the function. Press alpha first, and this is X times Z plus, where's the Y? Oh, Y, and then the let's see if it's right. X times Z plus Y squared ds. Yeah, it looks pretty good. Okay. So it's okay. What's given here is given RT, you know, I, J, and K. So we choose number 6 on that one. Wait for the program to load a little bit. And we're going to enter these functions here. One thing I wanted to tell you is that this minus sign in front of the 7 is different than this minus sign by the T. And I don't know what you call them. Let's see, this is the minus sign before the 7 is here, and the minus sign actually subtract things is this one here, this key over here in the calculator. So you have to do that, but you have to press alpha first. Okay, so you'd press alpha and then press this down here, etc. Now I've already entered all these into the simulator, so we're just going to go through them quick. Here you have minus T minus 7. The calculator turns it around here. J is 2T and K is minus 2 times T, okay? Say it's okay. Enter the range. You'd press alpha before any one of these now. Make sure you know how to do that. 0, T, and then 1. That's good. We find the derivatives. Here's I, we find the derivatives, minus 1. J, find the derivatives, 2. K, minus 2 is minus 2. Now you can probably do these derivatives. They're pretty simple, okay? At least you should be able to. So no problem. Now we're going to find ds, which is the magnitude of the derivatives squared as there's in the square root of the squares. Here's derivative of I squared, J squared, K squared, okay? Because we found the derivatives before, okay? So here we're entering it here, minus 1, 2, and minus 2. And we're going to square them. It equals these right here. It equals a nice easy square root of 9 and 3. Notice that these are all baloney line integrals. Well, all of calculus is baloney, I think, after 25 years. And here's, turns out to be 3. Isn't that convenient? But yet on the internet they'll say a line integral is the finding the area of a line or some string or wire or mass of the wire or stuff like that. They dream all this stuff. So this 3 would be supposedly finding that. And then we substitute the t's. Okay, so every one of these t's over here we're putting into the for the x and y and z values. Okay, here they are. Now the calculator does quotation marks. If you were to do this exactly in your paper, you'd have to put parentheses around these quotation marks to show that you're substituting them for the x, y, and z values in the function, original function. And then here's what the ds turned out to be. Remember the 3 here? So we take the 3 outside of the integral. Always constants always come out of the integral before you do your integrations. Try to simplify them as much as possible. And here we have 2 times t times the, this is a factored situation here. And we're going to, can you do the integral of this right here? Huh? Without the calculator? Maybe you could. Good luck. So we integrate it. Here's t squared times 2 times t plus 7. Okay. Over the range of 0 and 1. Remembering this outside the integral at 3. At t equals 1, the function equals 9. Okay, when you substitute the t's for 1. Substitute for 0, it turns out to be 0. Upper minus lower. And here's what was outside of the integral times 9. Answer is 27. Pretty neat, huh? Every step calculus.com. Go to my site, buy my programs, and pass calculus. I don't know what you're waiting for. Why would you ever study this crap by yourself and hours and hours and what are you going to study? Yeah, fine, you can do a derivative if you're smart. You have to learn how to do that really quick in calculus, no matter if you have my programs or not. And do simple integration, So you need to do that really quick in your head, be able to do that. But then when you get into the tricks and all the rules and stuff, impossible to memorize all that crap, and then there's no reason to memorize it. So why, your brain automatically says, why should I do it? It's no reason to do that. Any more than you should be studying Latin, for instance, or imaginary numbers, or crossword puzzles, or Sudoku. All a waste of time unless you're interested in it, or a math major. Fine, go for it. I don't know, no problem. But I mean, when they make you take calculus, you want to get out of that class and get your degree. And it's extremely difficult, let me tell you. So anyways, go to my site, buy my program, and pass calculus. Hey, have a good one.